Hello and welcome to this short introduction to our memory pooling package. We have a sample scene set up to walk you through using game object pooling. It contains a cube fountain that spawns cubes and throws them every which direction. The completed scene is included in the asset store package and we encourage you to check it out. To start, we are going to import the Unity package and set it up. Notice the automatically created singleton KDispatcher object in the scene. We are going to move the folders editor default resources and gizmos out to the assets root. To ensure consistency, we are going to also save the scene and do a reimport all. Next, we are going to add the kpoolable game object component to the cube object. Notice the warning in the inspector prompting us to move the prefab. For a closer look at things, we're going to open the Game Object Pool Manager window. As we switch to play mode, a pool of cubes is created using the default values, but the cubes are still using instantiate. Time to set up the code. Using the included code snippet, we are going to create a Boolean configurable setting to toggle the use of game object pooling. Note the ample comments dropped in. They outline steps that need to be completed for the setting to be functional, some alternative use patterns, and a couple of cautions. Once we've run through the to-do checklist, we can get rid of them. Now, based on the setting we created, we need to grab an object from the pool. This only takes one line of code. Recovering the object back into the pool also only takes one line of code. Making our behavior inherit from kpoolable mono behavior allows us to define initialization and reset methods that are automatically invoked by the Game Object Pool Manager. Initialize will be called only once when the object is initially created, whereas reset will be called every time the object is requested from the pool. With the code in place, let's open up the config editor and enable game object pooling via the setting we created. Switching to play mode again, we can see the objects marked as pooled instead of clone. Also note the E. This means the pool was initially too small and needed to expand to cope with the number of objects we requested. Note the kGameObjectPool in the scene hierarchy. This is a container for unused pool objects. We can use the setting to enable or disable pooling at runtime. Stopping play mode, the scene hierarchy is cleaned up. Switching to the Game Object Pool Manager window, we can see the learned data has changed. This new value will be used as the initial size for the pool on subsequent runs of this scene. Now let's see what happens if we forget to recover some objects. We need to set logging to be more verbose and make sure debugging and logging are enabled. With that done, when stopping play mode, any unrecovered objects will be logged, listing the type and method that requested the object and forgot to return it. Our tools keep their own logs under Unity's persistent data path in the folder kxlogs. As we improve the package, we hope to add more precise debug data. Let's see what happens if we try to instantiate an object that's not in the right location. The pool manager will try a few alternatives and warn if it comes up empty. The inspector notices the faulty location and offers to move the prefab. Now let's try instantiating an object that is lacking the poolable component. The pool manager will warn of the issue and resort to using GameObjectInstantiate to supply the object. When trying to recover one of these objects, there will be another warning and GameObjectDestroy will be called. That wraps up the basic functionality when dealing with game object pools. We encourage you to check out the sample scene and the documentation. Thank you for your time and have a great day.